Denavit Hartenberg parameters allow you to succinctly describe the motion of a series of rigid joints. This is useful for efficient calculation of forward and inverse kinematics. The process begins by defining the z-axis, along the axis of rotation for our VUU joints, or the axis of translation for prismatic joints. Since this is the first joint, the x-axis is a free choice. For later joints, each x-axis will point away from the previous joint. The y-axis simply completes the right-handed reference frame. Now if we add another joint, we can determine the transformation between them. As before, the z-axis points along the axis of rotation. The dh parameters will be derived from the common normal between these z-axes. The common normal is orthogonal to both vectors, and is also the shortest line between them. The new x-axis points along the common normal, and has its origin at the intersection with the new z-axis. Notice the origin is not within the physical actuator, because the dh parameters are only concerned with the motion of the links, not the physical placement of components. Using this protocol for laying out the reference frames, only 4 parameters are needed. The first of these, d, is the depth along the previous joint's z-axis, from the origin to the common normal. Theta rotates about the previous z-axis to align the x-axes. R is the length of the common normal itself. Most texts call this parameter A, which is unfortunately easy to confuse with alpha. Instead, calling it R is a useful mnemonic, as this is also the radius of revolution for the new origin about the previous z. Finally, alpha rotates about the new x-axis to bring z into alignment with the axis of joint motion. Now there's one special case, when the z-axes are parallel. Because parallel lines have an infinite number of common normals, you can choose any d value you like in order to place the new origin at a convenient location, such as the center of a link or the tip of an end effector. The other parameters are the same as before. Theta rotates about z to align the x-axis with the normal, and r translates out along the normal to reach the new origin. Alpha is already known to be 0 in this case, since the z-axes must be parallel for this to apply, thus no rotation is needed. Congratulations, that's all there is to it.